My name is Alessio Basso. I'm a principal architect with AWS. And today, I'm going to be on stage with my colleague Charles from the prototyping team to tell you how AWS help companies like yourself improve their retail and supply chain experience using cloud tools. Good. We're going to talk about the history of retail, how the experience for a customer doing shopping evolved from the very beginning till e-commerce nowadays. We're going to talk about how AWS help retail customers like yourself to solve specific problems that they have in their supply chain with the help of the prototyping team. And we close on how we leverage all the experience that we built in years operating Amazon.com supply chain on a new service that we built and released very recently, AWS Supply Chain. Customers' expectations are increasing, and customers are expecting suppliers and retailers not only to meet their expectations, but exceed them. Customers especially choose a retailer or a place where to shop based on convenience. Convenience means many things, depending on who you ask for. Regardless, retailers need to modernize their brick and mortar shops. They need to digitize them, and they need to apply technologies to successfully engage customers with data and automation. Let's backtrack a bit and look at how this evolved through the years. Decades ago, my parents, your parents, our grandparents used to do all their shopping in small neighborhood stores. They go there, they buy everything from hardware to food to clothes. And the shopkeeper, which was also the owner, knew them by name and was able to provide personal recommendation that, of course, were fostering loyalty. Fast forward a few years, there was consolidation in chain stores and malls. Basically, what happened is that many products and many different shops were consolidated in one single location. Of course, the scale had advantages. Products were cheaper and there was a bigger selection. But it was harder to find amongst all this selection. It was harder to find what you were actually looking for. And of course, it was very hard to get recommendation. You know, staff that was manning those stores was normally not know what your preference is, and they were not able to give recommendation on the specific products that they were selling. And fast forward to these days, e-commerce is similar to the mall initially. You had a lot of choice. You have low prices and the added convenience of delivery. You didn't have to drive to a place to buy stuff, but it was even harder to do selection, right? Because in a physical shop, you can try the items, you can try them up if they are closed, for instance. E-commerce didn't provide this capability. So what you actually want, we found out, is the personalized service of a mom-and-pop shop, you know, having customized recommendation with the cost efficiencies and the convenience of scale, which is what e-commerce and malls give you. And technology actually solved this in various ways. We have now recommendation algorithms that personalize your experience so that every customer gets a different experience and different recommendation based on their preferences. Customer support tools that allows you to have a direct conversation with a customer support representatives for things like refunds or replacements. And of course, online to offline, where you go to a shop, you try out the items, see if they're okay for you. And when you click purchase, the order is fulfilled by the highly optimized supply chain that powers the e-commerce store. That said, as Jeff Bezos says once, customers are always beautifully, wonderfully dissatisfied. So as the retail kept pace and improved their service in a way that we just saw, our customer came to expect more, came to expect to be recognized as valuable customer across online and offline channels. They want more and more recommended curated products based on their preferences. They want to have immersive experience. They want to have promotions, discounts that are specific to the situation they are in. And of course, they want to be treated fairly, respectfully, and quickly, efficiently when issues arise. To support that, demand, businesses like yourself need to reinvent the way they do business and they architect their supply chains. Automation, of course, machine learning, those are all tools that you can use, but data is the driver. And I'm not talking about data about individuals only. Data about individuals is useful because it helps you to create personalized experience, but aggregated data about customers, about operations is really what is useful because it helps retailers and manufacturers to decide which products are going to be more successful and create new products that the customer wants. And data in aggregated format can be used to forecast demand. So companies can acquire, replenish, and stock inventory more efficiently. And of course, this efficiency will translate in lower cost for the consumer. And AWS provides the deepest and broadest set of machine learning tools that help you do just that. Since we are Amazon, when we talk about retail modernization, the mind probably goes to Amazon's Go and the Just Walk Out technology. As your company, you may not see this type of automation, this type of technology as a priority, and that's okay. You know, we all maybe want this seamless experience where you walk into a store, you grab your stuff, and then you leave without checkout, without queuing, without paying. But there are a lot, many other ways when you can improve the experience for your customers without having to implement the North Star that we can see here on the screen. There are many touch points across the whole journey that are ripe for improvements. From the first image when a product is manufactured to when it's moved to distribution centers and eventually to the retail shop, when it ends up on the shelves and your customer browse the aisle and decide what to buy, when they buy and pay for it, maybe using loyalty points, when the product is finally delivered to their home, and when they may end up, filming an unboxing video and sharing it on social media. Now, we help companies like yourself to build solutions to address each and every one of those touch points. And I want to invite my colleague Charles, which is leading the ASEAN prototyping team, to give you an example of 3 customer pain points that we did solve on 3 touch points. One is demand forecast, the other one is delivery optimization, and a third one is shelf depletion monitoring.
Hello everyone. Hi. My name is Charles Rouspeir. I'm leading the prototyping team and prototyping program in ASEAN. So, as Alessio mentioned, we have at Amazon our North Star with Amazon Go Store. But not everyone is there. And to go there, actually, at Amazon, we embraced the fact that we needed to experiment a lot. It was not made into one iteration. We needed to experiment, make a set of assumptions, try those assumptions, verify them. So for us to innovate, we believe that it's very fundamental, capital, to be able to do those experimentation as a way to change and transform your business. But the second part of that is that if you experiment, you need to accept the fact that some of those experiments may fail. And it's very important to us. And that's how we've made progress through time. So to that extent, and to help customers who wants to innovate but don't really know how to start and what to do, we have created this program, the prototyping program, and we're really here to help code hands-on with you into your most challenging use cases and trying to identify how emerging technology can help transform your business. So let's dive into the 3 stories that Alessio mentioned. Let's start first with a first customer who's one of the largest tech food retail in ASEAN. They're totaling thousands of physical stores, and they also have a website, and so they need to support both operations. So what was the business challenge? The challenge was to manage better the supply chain and the inventory because of all the large level of demand. So the customer relied on manual processes, domain experts, and so on to try to identify what were the trends and how they could best forecast and try to predict where they needed to put the effort. But that led to a lot of inaccuracies. So we helped the customer build a solution capable to automate the whole forecasting of product demand based on existing stock and historical data, and to provide insights to the planning team. For example, what type of product do you need to order? Where do you need to position those different products, and so on. So let's take a step back and let's try to look even at why does it matter? Well, it matters because forecasting is basically about the science of predicting the future. By examining historical trends, you want to be able to anticipate where again, the next demand will happen and where you may have increase of demand and when and where and so on and how to allocate your effort. Because if you under forecast or if your forecast is too low, it means that you will underinvest, which means you won't have enough product to fill your demand, which leads to poor customer experience on one side, but also means to lost opportunities, loss of sales. So that's very important. On the other side, if you're over forecasting, the problem is that you have too much inventory now that you need to get rid of and potentially take space, and you basically took some of your own money to put on that specific item or set of items. So that's why it's so important. And today, companies are using every type of tools from Excel spreadsheet to other type of services and softwares in order to try to anticipate. What we have seen is that using a machine learning approach actually usually increase around 20% of the accuracy of the prediction and leading to 5% inventory reduction and in most cases around 3% increase of revenue. So let's switch back to the context of our customer and let's look at how it came to life. So our first challenge to consider was the fact that the customer is great at their business, but machine learning and technology is not their business. So we need to create a solution that could be easily applicable to them. So we looked at Amazon Forecast, was one of our service, as a way to start because it requires a set, it was really matching the capability and the skill set of the team. Using the Amazon Forecast, the customer was able to train their own model on their own data in order to start predicting the demand. With this simple setup, so on one side you can see that you have the pipeline is relatively, or the workflow is relatively simple. You have your data source as a start. In that case, it was a S3 bucket with some data that were being uploaded. You have then a layer of transformation of your data, and that was done through a low-code solution that we also have with Amazon Glue. And the third part is the machine learning. Then you create an endpoint so you can very easily query and start doing your predictions. So with this very simple setup, we managed to help the customer achieve 57% mean accuracy on a 14 days of forecast window. The workflow is fully automated with an interface for the customer to use. Again, no need for machine learning skills. The model learned by itself on the data and can be increased and extended. The third element is that it's extensible. So here we are talking about forecasting, but the exact same pipeline, data transformation service can be applied to other services that Amazon provides. In that case, it could be about fraud detection in order to verify that transactions that are happening among a certain, beyond a certain amount. It could be also about personalized, to do some product recommendation in the mobile app of the customer. It could be any kind of custom model also. The pipeline remains the same. And talking about extensibility, actually, the forecasting capability alone helps remove many other pain points than just the inventory planning. It helps, for example, with the workforce planning, the capacity planning, or the financial planning. So if you're interested by using similar capabilities, you can reach out to your account team so we can be in touch, or also look at the Amazon AWS Marketplace, which gives you access to a broad range of trusted third-party solutions, including SaaS, data, and professional services to help you innovate at speed, with features to help you modernize your digital supply chain and operate at scale. Let's now go into our second touch point, still in the retail value chain, still in the logistics side, but this time for a customer delivering products and items, both from warehouse to store and from store to customer doorstep. So what is the business problem here, or the business challenge? Well, a customer has a large fleet of vehicles of different types and different sizes. They needed to improve their delivery allocation efficiency across their vehicle. So they asked us to look at improving the delivering scheduling and optimization of routing of their fleet. So the fleet of vehicles basically needs to be matched with the orders, which then has an impact on the trip lengths, which also has an impact on the bottom line because the cost associated to the operating of the fleet of vehicles. So this is a complex problem to solve actually, because we need to consider a large amount of parameters and constraints such as the valuability of per vehicle, the size of the parcels to deliver, and so on and so forth. So we also need, by the way, to maximize the space used per vehicle, reducing the empty space per vehicle, for example. So while at the same time, we also need to minimize the overall distance the driver has to drive within a day. So you can see the objective here is really to optimize the path of the driver and while minimizing the unused space per vehicle. At the end, we come up with a recommendation in terms of planning, which all the different trucks or vehicles that the company has, and what is the best and optimized allocation of space. So to solve these problems, let's just take a step back and look a little bit at the different constraints we need to represent. First, we have what we call the contract information, which are some of the parameters basically composing a daily schedule. It's the start and end date, the routes, and the package sizes, and those can differ. Then we have the hard requirements, which needs to be implemented and needs to be respected, and the good to have requirements. On the hard requirements, as you can imagine, you have the fact that all the trips covered are included into a contract. The truck has enough space to transport all the packages. All the trucks deliver before the contractual deadline. Those are the fundamental constraints we need to represent into a problem. The good to have are parameters such as how you can optimize the space utilization, how to minimize the underuse of our resources and your space. And finally, yes, basically how you can look at the fleet level, not only at the truck level, but generalize those constraints at the fleet level to really optimize the way the business is operating. So by leveraging a mix of AWS capabilities, some of our services, and even open source libraries, we have built a linear optimization tool which allows to address all the challenges mentioned, including calculating the best routing, options for vehicle across deliveries, support the batch order distribution, optimize the capacity utilization per vehicle. And there's more actually, because we help the customer easily integrate their own business constraint to the tool. Because you could have specific argument based on a specific region, province, or area of a city. We give also the business a 360 view in near real time of how the business operating. If we are looking at how the result or the before versus after, you can see on the left actually how the tool works. And really, it's a simulator actually where simulating actually the driver route within a certain day. And you can see actually at the level, at the task level, actually how the different elements go from pick up, drop, drop, pick up, and all of that is optimized in order to minimize the overall cost of driving through a city. If we're looking on the right side, you see some other results, and I would like to get your attention on 2 points. Is that optimizing, by building the optimization layer we did, we were able to lower the vehicle usage while supporting an increased volumes of orders. And why is that so important? Because it enables the customer to free vehicles use so they can grow the business even further with the same fleet. They can start tackling all the orders because they have a better optimization and a better allocation. Let's now look at our third prototype along the journey that Alessio mentioned, and with another use case, and this time it's about how we help a customer leverage computer vision to better keep track of their in-store inventory. Here, the customer challenge is that the customer operates a series of stores and they need to fulfill on a daily basis both in-store and online orders, which bring a lot of tension on that supply chain because they need basically to have someone monitoring constantly between the different type of orders, how many items are left. So here, it leads to poor customer experience when your stock is low and you didn't prepare it and you were not aware and you didn't anticipate it, but also poor employee allocation because your employee needs to run through the store during the whole day. So in this context, again, a customer didn't have any machine learning experts. So we looked at how we can leverage another service. Again, the objective is really to go fast to establishing a baseline that they can start using. So in this context, we use Amazon Recognition and the custom labels in order to create a machine learning model, computer vision model that can be trained on the customer data. Some of the core benefits of the approach is that it doesn't require any machine learning expertise on one side. It's a low code, no code, drag and drop, pull data here and there, train, label the data, and train the model, and then the model learns to recognize the objects. It requires, because you benefit from the trainings that Amazon has done to build a service, it requires far less data to train. We are talking about tens or hundreds of pictures, where previously, if you were building your own custom model, you would need thousands or tens of thousands actually of images. The last benefit is that it's fully managed by AWS, so it means you can very easily integrate it to your own environment and build quickly on it and integrate it. So we start by experimenting. It's all about experimentation with the prototyping program, and we went to try to conceptualize how the different cameras will play a part and how we will display those cameras, because we had a lot of uncertainties. We were not aware of what was the best solution. So we went and we looked at 3 setups, putting camera on the center, on the front, and at the edge. We went physically in the store to try to position those cameras and try different setups. That's you see us in the store of our customer. And the process is very simple, actually. We are taking a picture every n minutes. We are analyzing this picture to detect objects or products. We're trying to identify if those products have been trained. Is it an item that we are monitoring? And then we are trying to calculate or count the number of objects. We have also some perspective analysis, so we can try to anticipate also if it's one layer or if there's different, again, estimate what the remaining stock is. If there is stock, if there is no problem of, we still see items, then there's no action. If we see that we are running low, below a certain threshold, we send a notification and an employee come and refurbish the shelf. Here, again, with this prototype, we help the customer understand the possibilities they could and should consider to improve their operations. The model build achieved between 90 to 97% mean accuracy, depending on the camera angle and the type of product. And the tool also gives the customer the possibility to train on their own new items. So if a new product is being sold, they can very easily tag it themselves and add it to the models, which is very important. So that's it for the 3 prototypes that we wanted to share. And again, those are custom-made based on customer demand, regional demands, and we are here to help the customers really innovate and try to experiment and start integrating that innovation mindset to the way they're operating. Now let's look at how Amazon.com, with a lot of expertise also and experience in the retail industry, try also to create solutions that are really helpful and accelerate the path to our customers. For that, please welcome Alexio back to the stage.
Thank you, Charles. And by the way, most of the prototyping team deliverables in terms of code and instruction on how to deploy this code are available on GitHub. So if you want to start from scratch, do it. If you want to content prototype, do it. If you want to go on GitHub, download all these prototypes and build on top of it, then you can do it as well. What you won't find on GitHub, though, is Amazon Supply Chain. So I'm repeating myself here. Supply chains are hard. They're central to everyday life, but they're very hard to get it right. That's why, as Amazon, we built a new service that we announced in reInvent last December and was recently released as general availability. So it's up for everybody to use. It's called Amazon Supply Chain. So supply chains are hard because of 3 reasons mainly. The first one is that data is typically scattered across silos in incompatible formats, and it leads to a lack of visibility. You have the data, you just don't have an uniform vision and view of the data. Even if you have the visibility, there are so many items in your data lake supply chain, up to billions, that it's very hard to separate what is signal from what is noise. And even if you can separate signal from noise, it's very hard to coordinate all the actions that you identify as an improvement on the supply chain. You get the insight, but actually execute on the insight is a third thing which is very, very hard. AWS Supply Chain solves the pain points that I just mentioned. It solves the connectivity and data problem by bringing all the data from all your ERP and supply chain system into one single data lake. It solves the signal to noise problem by using machine learning to create insight on this data. And it also solves the coordination problem by providing tools that your team can use to coordinate actions across all the companies that participate to your supply chain. How do we do this? Well, first, you need to free the data. We created a supply chain data lake where we can ingest all data sets from your ERP system or all the other IT systems that make up your supply chain. We support a lot of different formats, and we are continuously adding on top of that. Second, we use machine learning powered data association to make sense of this data that we are importing. We have a canonical data model that we built, and we use machine learning models and natural language processing to read the data sources that you connect and then map to this canonical data model. After we have the data in the canonical data model, we use machine learning tools to derive actionable insights on identifying what the bottlenecks of your supply chain are or what the risks are, and we display them on the screen. And of course, on top of that, we use machine learning to recommend which actions you may take to solve and address those risks. And then we have contextual collaboration tools to make the actionable easier. Enough of theory. You all want to see how this looks like, and that's a screenshot of what you, as an inventory manager, will see when you log into AWS Supply Chain. You will get an overall view, in this case in a map view, of all the facilities where you have inventory and the overall health of your inventory. And of course, you can drill down for detailed inventory levels for a specific location. You can also set up watch list if you want to do it manually, or you can let AWS Supply Chain do the job, and they will surface ML insights and potential risks like stockouts or overstocks, and they will be displayed in this sort of Kanban board view. The application, of course, learn based on all the risks that you observe and all the actions that you perform. Once you identify a risk, like for instance this stockout risk in the Atlanta distribution center, you click on it and an overview of the risk is displayed. And if you look at the bottom part of the screen, you see 3 options for resolving this risk. So in this case, this is a stockout risk. So the recommendations are, well, move some units from a different fulfillment center to this Atlanta fulfillment center. And you can see that the rebalancing options are all scored by an inventory risk resolved percentage, which basically tell you how likely is that action to solve this out of stock risk. Overall score in terms of complexity, distance between the 2 facilities, and of course also the CO2 emission of that particular action. A lot of companies these days, as we saw in the keynote this morning, they are interested in minimizing their carbon impact, and this is just one other tool that we provide you that help you do so. After you identify which actions you want to take, you click in, and a contextual collaboration tool like a chat like this bring all the actors in your supply chain that you need to communicate to solve this risk in one single chat. And the powerful thing is that the details about this stockout risk are always visible on the right side of this chart. So everyone across the supply chain working for different companies in different time zones always has access to the data they need to take action to solve this supply chain risk. Of course, we also have embedded a demand planning tool. This is the same machine learning driven planning capability that we use for Amazon.com. And this is something that you can use to forecast demand for your product in the supply chain. This is embedded in the tool, or we can build a dedicated one for you, same as the Charles' team did for the customer I just mentioned before. So to summarize, AWS Supply Chain knocks down all the problems that we highlighted before in terms of visibility of supply chain. You can quickly gain visibility across the supply chain by aggregating data from different data sources. You can use machine learning to identify insights, recommend action, and make more informed decisions. And you can resolve issue quickly with this chat collaboration tool that we just displayed. You can do this with the usual pay-as-you-go model that you expect from a cloud service. You subscribe, this is a business application, web access, the point-and-click interface to set up your ERP and your other integration is easy to use, and you don't need to have a development team to set it up. I'll show you 3 examples. I introduce you a service that Amazon give you to optimize your supply chain. So my call to action today is something that Jeff said once, which is you listen to your customers, so you fulfill their demand, but don't just listen, also invent on their behalf and build something that they don't expect, they don't know they yet need. My call to action today is to build this together. So if you are in the business of optimizing your supply chain, come talk to us. We can do a prototype. We can walk you through, use the tools that the AWS Cloud can provide you to improve your supply chain and improve at the end your customer experience. Thank you so much.